Hello students, good evening everyone, good evening. I'm your physics teacher Vikal, and yesterday we have discussed about thermal equilibrium and first zeroth law of thermodynamics. So today we are going to start next topic, that is heat, internal energy and work. Okay, so some basic overview we have discussed about heat in last class, okay, in yesterday's class. Okay, so today we will discuss heat in some detail. So firstly, we have to understand what is heat. What is heat? So heat is basically energy in transit. Transit means, good evening everyone, good evening. Transit means ट्रांजिट का मतलब क्या है? हीट इज एनर्जी इन ट्रांजिट, मतलब हीट किसी सिस्टम में नहीं है, हीट रास्ते में, हीट इज इन वे, ओके, इट इज इन सम पाथ, it is not in any system, okay. So heat is energy in transit, बीच में है कहीं पे, ना ही किसी एक सिस्टम में ना ही दूसरे सिस्टम में, हीट कहीं बीच में है. अगर वो किसी सिस्टम में पहुंच जाती है तब उसको हम लोग हीट नहीं बोलेंगे, उसको क्या बोलेंगे वो हम देखेंगे, वी विल डिस्कस अबाउट इट. ओके, सो हीट इज एनर्जी इन ट्रांजिट. ओके, नेक्स्ट पॉइंट इज ऑलवेज फ्लोज फ्रॉम हायर टेम्परेचर टू लोअर टेम्परेचर. Okay, heat always flows from higher temperature to lower temperature. हम लोग देख सकते हैं, we can see in our general life, like if we have a hot cup of tea, so after some time what will happen? Its temperature will decrease, it will become cold. Why? Because of our ambient temperature. Whatever is the temperature of our ambient or atmosphere, tea will also become of that same temperature. It will come into thermal equilibrium with the atmosphere. Okay, so heat always flows from high temperature to lower temperature. Okay, understood this point? Next is heat flow stops. That flow stops when temperature equalizes. That means if two systems will have same temperature, then there will be no heat transfer between them, there will be no heat flow between them. Understood? So always heat flow will be there, heat will transfer or heat will flow when two systems are having different temperature, and it always flows from higher temperature to lower temperature. It never flows from lower to higher, it always flows from higher to lower. Okay, जनरल लाइफ में हम लोग देखते रहते हैं, हमेशा हायर टेम्परेचर से लोअर टेम्परेचर पे ही हीट ट्रांसफर होता है. कभी ऐसा नहीं होता कि ठंडी चाय गर्म हो गई अपने आप, इट नेवर हैपेंस. ओके, सो हीट ऑलवेज फ्लोज फ्रॉम हायर टेम्परेचर टू लोअर टेम्परेचर. और वो फ्लो कब स्टॉप हो जाता है? व्हेन टेम्परेचर इक्वलाइजेस. दैट मींस टेम्परेचर ऑफ बोथ सिस्टम विल बिकम इक्वल. Okay, good evening everyone, good evening. Okay, now next point is heat is a mode of energy transfer to a system. If we want to transfer energy to a system, then by mode of heat we can transfer it. So heat is a mode of energy transfer. By the help of heat we can transfer energy to the system. ठीक है? ये कल नहीं हुआ था, कल zeroth law of thermodynamics हुआ था और thermal equilibrium हुआ था, और कल you are not in class. Okay, so mode of energy transfer to a system. Heat is a mode of energy transfer to a system. Okay, now one very important point is it is not a state variable. It is not a state variable. It depends on path. It depends on path. अब इसका मतलब समझते हैं हम लोग. गुड इवनिंग एवरीवन, गुड इवनिंग. इसका मतलब हम लोग समझते हैं कि heat is not a state variable. It is a path variable. It depends on path. इसका मतलब हम लोग समझते हैं. ठीक है. If we have two systems, not two system, we can say like if we have a system consist of gas. हाँ, thermodynamics में क्वेश्चन करेंगे हम लोग. Okay, so if we have a system, assume it is a system which consists a gas. Okay, so its temperature, its pressure, it is having some pressure P naught, it is having some volume V naught, and its temperature is T naught. Okay, so this P naught pressure, V naught volume, and T naught temperature, these three quantities are its state variable. State variable. If you will heat this gas, then what will happen? Its temperature will increase. After some time, its temperature will change to, like you can say, T dash. Volume will remain same. Pressure will also change, P dash. Okay, so when we will give heat to the system, then what is happening? Its state is changing. Its state is changing. Okay, but to change its state, we have so many infinite number of process. How can we change its state? How can we change these quantities? Like अगर हम लोग को pressure change करना है, इसका pressure change करना है P naught to P dash, तो हमारे पास बहुत सारे तरीके हैं प्रेशर को चेंज करने के. इनफाइनाइट नंबर ऑफ तरीके हैं प्रेशर को चेंज करने के और टेम्परेचर को चेंज करने के. ओके, सो दोस तरीके, लाइक दोस प्रोसेस आर, वी कैन से डिपेंडेंट ऑन पाथ. वी कैन से पाथ. तरीके मतलब हम लोग किसी भी रास्ते से जा सकते हैं. देयर आर सो मेनी वेज. Like if you are going to like from one place to another place, so we can go from one place to another place by so many path, through so many path. Okay, so heat is a path function or path variable. Like by keeping temperature constant, if you want to change this pressure, then heat will be different. Heat given to the system will be different. By keeping temperature variable, if you want to change pressure P naught to P dash, in that case heat will be some other value, some different value. Okay, so heat is dependent on path. Path means process. We will discuss about some processes like isothermal process, isobaric process, isochoric process. Okay, so heat is dependent on process. It is not dependent on state. Understood? So heat is not a state variable. It is path function. It is path variable. It is dependent on process, by which process we are changing the state of the system. Understood? I hope all of you understood how heat is path function. Okay. Okay, now we'll understand what is internal energy. What is internal energy? Okay, so internal energy is what? Sum of kinetic energy and potential energy of molecules. Internal energy is what? Sum of kinetic energy and potential energy of molecules. And this internal energy is not dependent on kinetic energy of whole system. Like, for example, if a system of gas is there, like if in a container we have a system. So if this system is having some velocity, that means it will have some kinetic energy, half mv square. So if the system is moving with some velocity v, in that case its internal energy will not change. Its internal energy is only dependent on kinetic energy and potential energy of molecules. It is dependent on these internal factors. Okay, so with what velocity its molecules are moving, and what force of interaction is there between the molecules. So internal energy is dependent on kinetic energy and potential energy of molecules, not on the velocity or kinetic energy of whole system. या molecules लिखा है, molecules. Okay, तो हम लोग क्या लिख सकते हैं? Kinetic energy of system as a whole is not relevant here. So whatever is the kinetic energy of whole system as a whole is not relevant here. So kinetic energy of whole system will not change internal energy of the system, because internal energy किस पे dependent है? Internal energy is dependent on molecules kinetic energy and potential energy, not on the system's kinetic energy. Understood? It's very important point. Okay, so understood what is internal energy? Relevant means kinetic energy of system as a whole is not relevant here. मतलब इसका कोई मतलब नहीं है यहाँ पर, मतलब ये इससे related नहीं है. Kinetic energy of whole system is not relevant means it is not related with the internal energy of the system. Understood? देखो, two different things are here. Kinetic energy of whole system, like ये container किसी velocity से move कर रहा है. Okay, so that is different thing that we have studied in mechanics. Here internal energy is dependent on internal factors, and those internal factors are what? Kinetic energy and potential energy of molecules. Gas के molecules कुछ velocity से move कर रहे होंगे randomly. Okay, so their some of their kinetic energy and potential energy will become internal energy of the system. नाम से समझ जाओ ना, internal energy means it is related to internal factors. And what is that internal factor? Kinetic energy and potential energy of molecules. Okay. Okay. Next point is internal energy. Internal energy is proportional to temperature, is proportional to temperature of gas. If temperature of gas will increase, its internal energy will increase. सीधा सीधा समझो, अगर इस सिस्टम ऑफ गैस को हम लोग हीट देंगे तो क्या होगा? What will happen? If we will give heat to this system of gas, what will happen? Its molecules will start moving very fast. And molecules will start moving very fast. That means their kinetic energy will increase. और kinetic energy increase होगी मतलब internal energy increase होगी. सीधी सी बात है. Understood? So internal energy is proportional to temperature of gas. So temperature, if temperature बढ़ा रहे हो आप, temperature is increasing, then what will happen? Its internal energy will also increase. Understood? So internal energy किस पे डिपेंडेंट है? टेम्परेचर ऑफ गैस पे. ठीक है. अब एक और इंपॉर्टेंट पॉइंट आया. जैसा कि मैंने लास्ट स्लाइड में बताया, as I told you in last slide, what are the state function? Pressure, volume, temperature. For a state, like at this time, this system is having this gas is having some pressure, fixed volume, fixed temperature. Okay. So fixed temperature means temperature is a state function. Temperature state पे dependent है. Temperature state of the gas पे dependent है. ठीक है. So अगर internal energy temperature पे dependent है, that means हम लोग कह सकते हैं internal energy internal energy is state function or state variable. अगर सिस्टम की स्टेट चेंज होती है, अगर सिस्टम की स्टेट चेंज होती है, लाइक आफ्टर सम टाइम its pressure will become P dash, volume will become V dash, or volume is fixed, here volume is fixed, and temperature will become T dash. So if T से T dash अगर चेंज हुआ है टेम्परेचर, कैसे चेंज किया हमें मतलब नहीं है. It is not relevant how we change the temperature from T to T dash. ठीक है. So internal energy is also not dependent on how this system changed its state. Here we can say state 1 and here we can say state 2. ओके, तो हमको ये मतलब नहीं है हमने कैसे चेंज किया टेम्परेचर, किस तरह से चेंज किया, किस प्रोसेस से चेंज किया, हमको ये मतलब नहीं है. हमको ये पता है यहाँ पे टेम्परेचर कुछ था और यहाँ पे टेम्परेचर बदल गया, ये हो गया, चेंज हो गया. ठीक है. तो वैसे ही इंटरनल एनर्जी भी डिपेंडेंट नहीं है किस पे, प्रोसेस पे. मतलब प्रोसेस मतलब पाथ पे, प्रोसेस और पाथ. ठीक है. सो इंटरनल एनर्जी प्रोसेस या पाथ पे डिपेंडेंट नहीं है, जैसे टेम्परेचर डिपेंडेंट नहीं है प्रोसेस या पाथ पे. सो इफ टेम्परेचर इज चेंजिंग T to T dash, similarly internal energy will also change because internal energy is dependent on temperature. ठीक है. So internal energy is also a state variable. It is not dependent on path. So we can write independent of path और प्रोसेस जो भी हो, इंटरनल एनर्जी प्रोसेस पे डिपेंडेंट नहीं है. हमको तो इतना मतलब है यहाँ पे टेम्परेचर T था, यहाँ पे टेम्परेचर T डैश हो गया. उसी तरह से इंटरनल एनर्जी यहाँ पे कुछ U होगी और यहाँ पे U डैश हो जाएगी. सो इंटरनल एनर्जी को हम लोग डिनोट करते हैं U से. ये भी एक इंपॉर्टेंट पॉइंट है, याद रखना. ठीक है. सो इंटरनल एनर्जी इज डिनोटेड बाय U, हीट इज डिनोटेड बाय Q. ओके. सो one more thing, heat and internal energy के बीच confusion होता है काफी. There is some confusion between internal energy and heat. So as I told you, heat is energy in transit and internal energy is the energy of the molecules, sum of energy of molecules, sum of kinetic energy and potential energy of the molecules. One more thing. As I asked you that temperature और potential energy का कोई relation है. Here we are dealing with ideal gases. Okay, so ideal gases का एक assumption लेते हैं हम लोग. Ideal gases में हम लोग assumption लेते हैं कि no interaction between molecules. मतलब मॉलिक्यूल्स के बीच में कोई इंटरेक्शन और इंटरेक्शन या हम लोग कह सकते हैं मॉलिक्यूल्स के बीच में कोई फोर्स नहीं लगेगा. और मॉलिक्यूल्स के बीच में कोई फोर्स नहीं है तो मतलब उनके बीच में कोई पोटेंशियल एनर्जी भी नहीं होगी. ओके, सो हियर वी आर डीलिंग विद आइडियल गैसेस, सो दैट मींस देयर पोटेंशियल एनर्जी विल बी जीरो. दैट्स व्हाई काइनेटिक एनर्जी, ओनली काइनेटिक एनर्जी विल बी देयर विद द मॉलिक्यूल्स एंड दैट काइनेटिक एनर्जी इज व्हाट, इंटरनल एनर्जी. Okay, understood. So that's why we are not bother about potential energy. Okay, simple. If temperature increases, then kinetic energy increases, and sum of kinetic energy of molecules is what, internal energy. Okay. Yeah. ठीक है. So one main difference between heat and internal energy. Okay. So if we are saying like a statement, I will write a statement. Okay. A gas has certain amount of heat. And second statement is a gas has certain amount of internal energy. Which statement is correct? A gas has certain amount of heat or a gas has certain amount of internal energy. I hope पहली स्लाइड में मैंने बताया था, as I told you in first slide, हीट इज एनर्जी इन ट्रांजिट। किसी सिस्टम के पास कोई हीट नहीं हो सकती। हीट क्या है? जो रास्ते में है। हीट क्या है? जो एनर्जी रास्ते में है, कहीं पहुंची नहीं है। ठीक है। हीट इज एनर्जी इन ट्रांजिट। तो ये स्टेटमेंट तो गलत है। इट इज रॉन्ग, इनकरेक्ट। सो अ सिस्टम कैन नॉट हैव एनी हीट, it can have only internal energy, because internal energy is related to its sum of kinetic energy of molecules. Okay, so second statement is correct. Understood? So there's a misconception, like कोई सिस्टम के पास ज्यादा हीट है या कम हीट है। कहते हैं ना, कि इस ऑब्जेक्ट के पास ज्यादा हीट है और इसके पास कम हीट है, तो ये रॉन्ग है, ये स्टेटमेंट गलत है। अगर टेम्परेचर ज्यादा है तो मतलब उसकी इंटरनल एनर्जी ज्यादा है। In daily life we say like this, if any object is hot, so we say it is having more heat. So physics के हिसाब से देखोगे, so that is wrong. According to physics, that if object is more hot, that means it is having more internal energy. Understood? So remember this statement. A gas has certain amount of internal energy, that is correct. Certain amount of heat, that is wrong. Clear? Chalo. Now we will understand work. In mechanics we have seen what was work. Work was W equal to what? Force dot ds, F dot ds, or we write it as F ds cos theta. Okay, in mechanics we have seen this formula. Here also we will use this formula, and we will derive new formula which is related to work done by gas. Okay, so I'm taking a piston cylinder arrangement. This is a cylinder, okay, and one piston is there. This piston is there. Okay, some gas is filled in the cylinder, and this piston is massless. Its area is A. Some gas is there in this cylinder. Now what we'll do, from this bottom we'll heat this gas. Now what will happen? Because of heating, this gas will expand. Its kinetic energy will increase, and it will start to collide with the piston, and it will apply some force on the piston. So what will happen? Piston will start to move. That means gas will expand. Okay, so after some time what will happen? This piston will reach somewhere here. Okay. So we are assuming like this displacement of the piston is dx. Okay. Okay, now small work done by gas we can write as F dot ds or F ds cos theta. So gases are applying force like this, and displacement is also in the direction of force. This is force applied by the gas, and this is displacement. Both are in same direction. That means theta will be 0. Theta is 0, that means cos 0 is 1. Okay, so we have to write only F dx. F dx. Okay, now as we know, gases will apply some pressure, like there will be some pressure of the gas. Okay, so by the formula of pressure equal to what? Force upon area. So we can write from here what will be force equal to P into A. Okay, so this PA we will put here, so it will become P what? Pressure of gas. Pressure of gas into area into dx. Okay, pressure of gas into area into dx. Now this term ADX, if you will see here, this is the area, and this is dx. So if you will see, this ADX will be what? Change in volume. What volume is there? That volume changing. Okay, so area into dx. will become what? Small change in volume, and that is what? That is ADX. That is what? That is ADX. Okay, so dV equal to ADX. So in place of ADX, we can write dV. So it will become what? P gas into dV. So this is the formula of small work done by the gas. dW gas is equal to P gas into dV. Okay. If you want to find total work done, so what we'll do? We will just integrate this P gas into dV. So simple, P dV. This will be the work done by gas on the work done by the gas. Simple. Okay, W equal to integration of P dV. Okay, if small work done, if you want to find that is P dV. Okay, so we are going to use both formula, W equal to integration of P dV or dW equal to P dV. One thing we have to remember, if volume increases, that means dV equal to what? Positive. That means work done will be positive. So means expansion is there. So simple, we have to remember, if gas will expand, that means volume will increase, that means work will be positive. Work done will be positive. Now, if volume decreases, that means dV will be what? dV will be negative. Okay, that means work done will be negative. So work done will be negative in what case? Compression. Okay, so when compression will be there, that means we can say volume is decreasing, that means work done will be negative. I hope all of you understood. So this was work done by a gas. Okay.